All right, for our next section, which is 23 through 39, we're still in Unit 2. You might want to look at your wheel of angle pairs to kind of help you with that. And also, we're going to start getting into Unit 4, which is the parallel line. So we have a orange, a little graphic organizer of all the types of angles formed with the transversal. To kind of focus on those two units, in a purple foldable that has like all the types of angles possible. So on 23 here, we have vertical angles. So you should be setting up vertical angles are congruent. So we should be setting this up equal to each other and solving for x. So here, I'll talk about what you need to do, or you're going to need to get, okay? Here we should get x equals 8. Here we should be using a triangle equals 180. So we should be adding up all three angles, make the equation equal to 180. All right. Here we should end up with x equals 50. Now when you get to 25, this is dealing with triangles. So this is our most current unit, which I think is unit 4. So hopefully you see that the 100 is outside the triangle. So this is your exterior angle. And then these two angles that they're showing inside the triangle are your remote interior. So abbreviate that. So here you need to be using the exterior angle theorem. And the exterior angle theorem states that your exterior angle equals the sum of the remote interior. So what's outside here, this 100, equals to these two added together. And that's our setup. We should end up, once you set it up, you should end up with x equals 23. Now, it kind of doesn't look like it with these arrows here on 26, it's trying to let you know that you got some parallel lines. So even if I want to extend this line, I could do a better job of that. Extend the line. Okay. To solve this, you would need to get to x, you will need to use your triangle that you have here. And with that triangle, you should be finding this missing angle here in this corner. If I find that angle, and I have parallel lines with these arrows, then you have alternate interior angles congruent. So I'm just kind of remember that. If the lines are parallel, your alternate interior angles are congruent. So if you can find this missing angle in the triangle, it's going to equal your x. Okay. On 27, you should be using our isosceles triangle theorem. This was our flip book. If I see two legs that are congruent, then you should know also the two base angles are congruent. So you would maybe start with this triangle here. I know that doesn't look so great, so let me fix that. Start with this triangle to get to these base angles. And all I have to do for that is take 180 minus the 120 divided by 2. Well, that's 60, so this is 30. And because we have these tick marks here, that means that this triangle here is the same as this triangle here. So our x is just 30. Because if I know the sides are the same, then the angles, oops, sorry. So I'll do that. These angles are going to be the same as well. 28, we're using that fact that we have these parallel lines, AC and DF are parallel. And we also have AE, so I'm going to do double arrow, and BF are parallel. So if I just kind of focus on these parallel lines here, because I'm solving for x, then this is the transversal. And what you're going to have with that is same side interior. Angles equal 180. So we should be able to add these two angles, and add them up and they equal 180. You should end up with x equals 50 here. So check your work on that. And then angle 1 is the x. Angle 2 here, the obtuse, is the 3x plus 4. Whenever we see adjacent angles on a line, okay, every line equals 180. So hopefully we're seeing that angle 2, sorry, let me kind of keep it color coded. Angle 2 plus angle 1 equals 180. So that's your setup. You should get, I believe, x equals 44 here. All right. So hopefully you're setting up the equation is solving for x. I think that's all they want you to do here is find the measure. No, we have to plug it back in. So we have to find the measure of angle 2 here. Okay. So we're going to have to plug it back into angle 2 and do 3 times 44 plus 4. All right. Now, for the next section, we're still in the same 2 units. So using angle relationships, some keywords. On 30, our keyword, we got to understand what bisects means. This ray BD is the bisector. The bisector, oops, I spelled that wrong, sorry. The bisector is the one that is doing the cutting. Okay. It's going to cut the whole angle ABC in half. So each one of these problems is going to kind of change because they're going to change the values here. On here, they're telling us what our angle 1 and 2 are. So if that's the bisector, then my angle 1 is going to be congruent to angle 2. And congruent means equal. So hopefully we're starting off here with the 2x minus 30 equals to 5x minus 120. And then we're just solving for x. They want you to find the angle measure. So you need to solve for x and then find the angle measure. So I believe if we solve for x here, we're going to end up with 90 equals 3x. So x equals 30. And then we got to plug it back in to find ABC. So I have to plug it back into angle 1 or angle 2. I'm going to just do 1. So this is 2 times 30 minus 30. So that ends up being 60 minus 30 is just 30 and 30. So the whole angle would be 60 here. Now for 31, we're not doing it algebraically. We're pretending like it now has this new measure. Sorry, right here where it says, oops, that the measure of ABC is 51. And so this whole thing is 51 and angle 2 is 32. So if this is 32 and yet the whole thing is 51, and let's say it's not a bisector anymore, okay, we just know that the whole is 51, then my 51 minus the 32 would give me my missing angle 1. So now we're just subtracting. So 32, since they're giving me the whole angle here, again, this is, oops, sorry, that looks bad. Since this is the whole angle, then the whole angle is going to equal our part plus our part. So you can use part equals whole to help you on this one. Angle 1 plus angle 2 equals 83. And then substitute the parts and solve for x on here. Yeah, they just want you to solve for x. It says right here, find the value of x on this one. So hopefully we get x equals 22 on this one. Now, determine the largest side. This is our last unit, the triangle inequality. That was in our blue foldable. So what we want to do is look at the largest angle, because largest angle is opposite or across the largest side. So I know this is 116. Opposite side is this diagonal. This is 90. See how they're pointing to the diagonal? So I can't use that. And then also I can't use it because we have two different angle measures here. So we're not going to use that one. We're going to go to the next largest side angle. I'm hoping y'all can realize that. So the next largest would be the 65. And then if I look opposite, that means the largest side is our LM. Congruent, two congruent angles that are not right. Well, I can physically see those right here, 25 and 25. When you name them, you can't say just L and N, because I don't know if you're referring to the 65 or the 39. You use 3 letters. So this would be angle K and L, and angle M, L, N. Our obtuse angle is our angle that is greater than 90 but less than 180. That is that angle that was 116. It's angle L, K, N. We have some more vertical angles. Okay, we did that on the previous page with number 14 and 23. So kind of refer back to those. These two are going to be congruent. We should get a whole number here. We have another exterior angle with the 5x plus 56. And then we have two remote interior angles. So, or we could use the triangle. So the methods can vary here, or you can want to start off with just the triangle, add it up, find the x, and go that way. So the methods can vary here. Here we should also be using, because we have a triangle, you can use triangle equals 180, or anytime I have a right triangle has two complementary, I'm going to abbreviate that, acute angles. So these two angles in a right triangle always add up to 90 degrees. So instead of doing all three angles, I can just do the 5x minus 5 plus the 6x plus 7 equals 90. You do need to plug it in. So you got to find your x so that you can plug it back in, because they want you to find the measure angle y. So that means you have to plug it back into that expression. Hopefully you get that the measure of angle y, doesn't look like a y, sorry, equals 35. And then our keyword on 39, this is A and B are supplementary. That means they equal 180, excuse me. So angle A plus angle B equals 180. And now we can plug it in. They want you to find the measure angle B. So work smarter, not harder. If I know my A is 30, 30 plus what equals 180? Yep, 150. We're done. Okay. If you use the n, it's going to come up with a different value. So that's our next check. That's part 2. We'll get into part 3 on the next video. All right, thanks.